Nearly 50 years ago, NASA launched the Voyager 1 spacecraft with a simple but ambitious mission to explore the outer planets of our solar system. Fast forward to today, and Voyager 1 is still pushing the boundaries of space exploration, traveling farther than any human-made object in history. But the spacecraft is now approaching a milestone that brings us face to face with the sheer vastness of the universe. As Voyager nears a point where it takes almost an entire day for its signals to reach Earth, scientists have had to change how they measure its location. Gone are the days when distance was measured simply in kilometers or astronomical units. Now, light time measurements are used, providing a much more accurate representation of the immense space between Voyager and our planet. This shift underscores just how enormous interstellar space truly is. Voyager 1 was launched in September 1977, and from the very beginning, its mission was set to explore the outer planets, Jupiter, Saturn, and beyond. During its journey, the spacecraft sent back groundbreaking discoveries from flybys of these planets. Its observations revealed new details about their atmospheres, moons, and rings. After completing these encounters, Voyager 1 continued its mission, heading into the unknown, beyond the reach of our solar system. Now, the spacecraft is over 160 astronomical units from the Sun, traveling at a speed of roughly 17 kilometers per second. At this distance, Voyager 1 is so far from Earth that it has become the most distant human-made object ever built. As Voyager's distance grew, scientists began to rely less on traditional distance measurements and more on light time measurements. Light time is the time it takes for a signal to travel at the speed of light from Earth to the spacecraft. Given the vast distance, this is a much more useful way of understanding the spacecraft's location. Today, a single signal sent to Voyager takes nearly a full day to reach it, and the return signal takes almost as long to come back. That means communication with the spacecraft can take over 40 hours for a round-trip exchange. Instead of using kilometers or astronomical units to describe its position, scientists now use light days or light hours, which more accurately reflect the reality of communicating across interstellar space. For example, a light day represents the distance light travels in 24 hours, about 26 billion kilometers. This new way of measuring distances also highlights just how far Voyager 1 has come. It's no longer a probe exploring the outer edges of our solar system. It's humanity's first attempt at long-term space exploration into the vast unknown of interstellar space. The spacecraft's journey is extraordinary, and it serves as a powerful reminder of human ambition and curiosity. Voyager's groundbreaking achievement isn't just about how far it has traveled, it's also about what the spacecraft is now exploring. In 2012, Voyager crossed the heliopause, the outer boundary of the heliosphere, the protective bubble formed by the Sun's solar wind. This region had never been directly explored before, and it marked the point at which Voyager entered interstellar space. Inside the heliosphere, the solar wind dominates, but beyond it, Voyager began to encounter the interstellar medium, the diffuse gas, plasma, and magnetic fields that fill the space between stars. Before Voyager, scientists could only study this region indirectly, but now, for the first time, they could measure it directly. Voyager has made a number of important discoveries in interstellar space. One of the most significant is the density of plasma beyond the heliosphere. Using its instruments to detect plasma waves, Voyager revealed that the plasma in interstellar space is denser than scientists had predicted. This finding has helped refine our models of how the solar wind interacts with the galaxy. Voyager also detected a significant increase in cosmic ray intensity as it crossed the heliopause. Cosmic rays are high-energy particles produced by powerful stellar events, such as supernovae. Inside the heliosphere, the Sun's magnetic field protects us from many of these particles. But beyond the heliopause, Voyager measured an uptick in cosmic ray activity. confirming that the heliosphere serves as a shield, protecting our solar system from these high-energy particles. Even more unexpectedly, Voyager detected that the magnetic field beyond the heliopause was not as different from the Sun's magnetic field as scientists had predicted. This finding suggested that the interstellar magnetic field near our solar system may be more aligned with the Sun's field than previously thought. This discovery has opened up new avenues for understanding the magnetic environment of interstellar space and how it may influence the broader galaxy. As Voyager 1 continues its journey into the unknown, its instruments are still providing valuable data, helping scientists learn more about the universe. However, the spacecraft is slowly running out of power. Voyager 1 is powered by radioisotope thermoelectric generators, which convert the heat produced by the radioactive decay of plutonium into electricity. These generators have allowed the spacecraft to operate far beyond the reach of the Sun, but their power output is steadily decreasing over time. To extend the mission as long as possible, engineers have been carefully shutting down instruments one by one, reducing the spacecraft's power consumption. This process allows Voyager to keep operating for as long as possible, but it also means that some of the spacecraft systems are being turned off. Communicating with such a distant spacecraft presents a number of technical challenges. The signals Voyager transmits are incredibly weak by the time they reach Earth. Detecting these signals requires some of the most sensitive radio antennas in the world. These antennas are part of NASA's Deep Space Network, a global system of communication facilities located in California, Spain, and Australia. The network enables engineers to maintain contact with spacecraft throughout the solar system and beyond, but it's only through the extreme sensitivity of these antennas that we can still communicate with Voyager 1. Another challenge is maintaining the spacecraft's orientation. In order to transmit data back to Earth, Voyager's antenna must be pointed in our direction. The spacecraft's thrusters, which had been inactive for years, had to be reactivated to keep the antenna properly aligned. This was a significant accomplishment for the team, as it allowed Voyager to continue transmitting valuable data despite its age and distance from Earth. Looking ahead, Voyager 1 is expected to remain operational until the early 2030s. After that, its remaining power will be too low to operate any of its instruments, and communication with Earth will cease. But even then, the spacecraft's journey will not end. Voyager will continue to travel through space, moving farther and farther away from our solar system. It will continue to orbit the Milky Way galaxy along with the rest of our solar system. In about 40,000 years, Voyager 1 is expected to pass relatively close to another star system. Though humanity will no longer be around to witness it, Voyager will still be on its journey through the galaxy, carrying a message from Earth. On board Voyager, 1 is a golden record containing images, sounds, music, and greetings from Earth. This record was designed as a message for any intelligent life that might one day encounter the spacecraft. The chances of this happening are slim, but the record serves as a symbolic reminder of humanity's desire to communicate and reach out to the unknown. Whether or not anyone ever finds it, the golden record will continue to travel with Voyager 1 as it drifts through the vast emptiness of space. As Voyager 1 travels on, its instruments may fall silent, but the spacecraft's legacy will live on. It will continue its journey through the stars, a silent ambassador of humanity, carrying with it a piece of Earth's history for millions of years to come. Even though it's now the farthest human-made object in space, Voyager 1 will continue to make history long after its mission has ended. It stands as a testament to the power of human exploration and the limitless possibilities of our curiosity about the universe. As Voyager 1's mission nears its end, we're reminded of the extraordinary journey this spacecraft has undertaken, from its early days exploring the outer planets of the solar system to its current position in interstellar space. Voyager 1 has redefined the boundaries of space exploration. It has provided us with invaluable data, revealed new phenomena, and has even answered questions that were once thought to be beyond our reach. But the journey isn't just about scientific discovery, it's about human perseverance, vision, and ambition. Despite the challenges that come with such an incredibly long mission, Voyager's instruments continue to send back valuable information from space. Over the decades, the spacecraft has measured cosmic phenomena, tracked the solar wind, and observed the magnetic fields of interstellar space. Each of these discoveries adds to our understanding of the universe and our place within it. Voyager 1's legacy, therefore, is more than just a collection of data. It's a story of how humanity has stretched its reach beyond our solar system and ventured into the unknown. Although the spacecraft is operating in an environment far beyond what scientists had ever expected, its continued operation and the data it returns are vital for improving our understanding of interstellar space. One of the more unexpected findings occurred when Voyager recorded a shift in the way cosmic rays behave as the spacecraft crossed the boundary of the heliosphere. The intensity of cosmic rays increased significantly, showing that the heliosphere serves as a protective shield against high-energy particles from deep space. Without the heliosphere, Earth and the other planets in the solar system would be exposed to much higher levels of radiation. Voyager 1's observations of these changes have been crucial in helping scientists understand the Sun's protective role in the galaxy. But as Voyager moves further into space, we must begin to think about the future. The spacecraft's mission is approaching its final phase, and the power from its radioisotope thermoelectric generators will soon be insufficient to keep the instruments running. For decades, these generators have allowed Voyager to operate in the harsh environment of deep space, but their power output is slowly diminishing. To make the most of what remains, engineers have been turning off non-essential systems and conserving power for critical scientific instruments. This careful management of resources ensures that Voyager can continue transmitting valuable data for as long as possible. However, like all good things, this mission will come to an end. As its power diminishes, Voyager will gradually shut down its instruments, one by one, and will eventually stop transmitting data back to Earth. When that moment comes, Voyager will still continue to travel through interstellar space, its journey never truly ending. The spacecraft is currently on a path that will take it out of our solar system and into the Milky Way, where it will continue to orbit the galaxy along with our solar system for millions of years. Voyager 1's message, contained on the golden record aboard the spacecraft, will carry humanity's story across the stars. Whether or not someone or something finds it remains a mystery, but the message represents humanity's hope for connection and exploration. The golden record contains images, sounds, music, and greetings from Earth, offering a snapshot of life on our planet at the time of Voyager's launch. It serves as a symbol of human curiosity, our desire to explore, and the eternal spirit of discovery. Even after the spacecraft has fallen silent, Voyager 1 will continue its journey through the cosmos. Its instruments may no longer be collecting data, but its legacy will endure. As it drifts through space, it will carry with it the story of humanity's first exploration into interstellar space. The spacecraft's journey is a testament to the determination of the engineers, scientists, and visionaries who made it all possible. It serves as a beacon of human achievement, one that will continue to inspire generations to come. Looking at Voyager's journey, we can see how far we've come as a species. What began as a small, ambitious spacecraft designed to explore the outer planets of our solar system has now become the farthest object from Earth. Continuing its trek through the galaxy, its success has paved the way for future missions to explore even deeper reaches of space. The data and discoveries Voyager has made over the years will continue to influence the study of space for decades to come. And while the spacecraft itself may eventually stop communicating with Earth, its contributions to science and human knowledge will never fade. As we reflect on Voyager 1's extraordinary journey, we are reminded of the limitless possibilities of space exploration. The spacecraft may have crossed the boundary into interstellar space, but its mission is far from over. It continues to carry out groundbreaking science, making new discoveries and enhancing our understanding of the universe. And as it travels on, it is a symbol of humanity's drive to explore the unknown, to venture into the vast and mysterious universe, and to seek out new knowledge. When Voyager 1's mission finally concludes, it will mark the end of an era in space exploration. But even then, the spacecraft will continue its journey through the galaxy, a silent ambassador for Earth. In the far future, it may pass close to other star systems, its golden record still intact, telling the story of our civilization to any intelligent beings that might encounter it. Whether anyone ever finds it or not is uncertain, but the fact that Voyager has traveled so far, carrying a message from humanity to the cosmos, is an achievement in itself. As we look to the future, we can take pride in Voyager 1's incredible journey. It is a symbol of the infinite possibilities of space exploration and a reminder of the spirit of discovery that drives us forward. If you enjoyed this journey through space and want to keep up with the latest in science and space exploration, don't forget to like, comment, and subscribe to the channel. Stay tuned for more exciting content on the wonders of the universe.